we will be uploading the video on what YouTube. Okay, so if any one of you want to have a watch on it, then you can just log on to our YouTube channel. It's by the name Swastik Edustart only. So this 4-day classes will be uploaded on YouTube. Okay, fine. So let me again come back to the topic. So a map can be called as a generalized view of an area. What is generalized? Generalized means if I am trying to, observe an area from above. Okay. So the importance of map was basically, or another definition of map is a geographical image of the environment. Okay. If I just want to see what features are around me, and if I want to map it, okay, or we can say map is a two-dimensional representation of the spatial distribution of selected phenomena. Okay, so two-dimension means map is always in two-dimensional format. Okay, and in map basically what we show the spatial distribution of selected phenomena. Selected phenomena means, look, in a map at a time we can only emphasize on a particular phenomena. Okay, like if you are a geologist, so you will obviously show the geological features. If you are a geographer, so either you will have the maps on socioeconomic parameters or the geographical features, right? You cannot create a map where you can show everything together. Why so? That is because of scale. Okay, so there are basically, okay, I'm coming, I think in this PPT only we will be emphasizing on scale also. Okay, so these are some of the definition of map. Okay, now the question is why we make map. Okay, so the very first reason, we make map to represent a larger area that we can see. Any query or what? I think someone has texted something. Yes, Gaurav Mishra, look, if you have any query, then please after the session you can ask me. Okay, अगर आप
Yes, ma'am. Thank you.
okay, so अगर आप लोग के पास कोई क्वेरी है अभी आप लोग लिख लीजिए. हम ये सेशन खत्म करने से पहले 10 मिनट्स का टाइम हम देंगे, ठीक है? बिकॉज इन द मीन टाइम करने से थोड़ा रिदम ब्रेक हो जाता है. I think sir is there to accept the students. Fine. So now the first reason we make map is to represent a larger area that we can see. ठीक है, पहला रीजन क्या है मैप बनाने का? अगर हम एक लार्ज एरिया दिखाना चाहते हैं, ठीक है, so suppose now what is this? Suppose for example I want to I want to make a study on the slums of Delhi. ठीक है, मुझे दिल्ली के स्लम्स का स्टडी करना है. सपोज आई वांट टू स्टडी द स्लम्स ऑफ दिल्ली, सो ऑब्वियसली आई हैव टू शो द होल दिल्ली. आई हैव टू विजुअलाइज the whole Delhi on my software, isn't it? And that I can do by creating a map. So in a map I can show the whole Delhi, and then I can locate the places where the slums are existing. Okay, so the very first reason that we make a map is when we want to visualize the whole large area. Or suppose I am trying to suppose find locate the desert in the world, wherever the deserts are located. So what I have to do if I want to see the whole world together? So that is a very large area, right? So I have to visualize the whole world on my software. So that's why the very first thing that we create map is to represent a larger area that we can see. Okay, another, to show a phenomena process we cannot see, right? So in map both we can, with the help of GIS, we can make map of the features that we can see as well as the features that we cannot see. Suppose I'm sitting in India, I want to study the glacier melt of Antarctica. So that is also possible. Now we have so many satellite images. With the help of those, we can, sitting at India, I can visualize Australia. I can do mapping of any country. That's why nowadays the GIS projects has been globalized. Now the companies in India are getting projects of America because location is not a factor in this particular field of study. You can sit anywhere and you can do work of any place, okay, that we even cannot see. The third reason of making map is to present information concisely. Now, what does this mean? So, suppose I want to make a map of the distribution of world population. Okay, so there are obviously countries having millions of population. So, with the help of map, what we can do? We can represent the population in some symbology. Like, for example, if I say that if I uh, if I say that a single dot is representing 1 million. Okay, 1 million. So whatever country, the country those will have more, suppose 10 million, so we can just show those with 10 dots, right? So this is how we are presenting a huge information concisely. We are concising the information. So that is another reason why we make map. Okay, the students, you should actually you should join on time. It's 8:45. Okay, so from tomorrow onwards, please do join by 8:30. Okay, don't be late. It will be your loss only. Yeah, so to show to present the information concisely. Okay, and another reason why we make map is to show spatial relationship. Look, this spatial term is very important in GIS. That's why even GIS is also called as spatial science. Now, what is this spatial? Spatial means whatever feature that occupies a space is called as spatial. Okay, and GIS it only understands the spatial terminology. Spatial terminology means the X and Y. Okay, I'm coming to that also. Anyway, so in the map we can also show spatial relationship. So suppose I want to create a map where I want to show the relationship between sex ratio and crime rate. Okay, suppose I took an assumption ki where the sex ratio is more, the crime is less. So these are two different kind of data, right? So in a map, I can easily show this two information together, and then I can show the relationship between these two features. So if you will do this work using some Excel sheet, and also the work will be too complicated. Whereas in the map, the things will be so simple, right? So these are some reason why we make map. Now the next question is, how do we read map? So whenever you get a map, how do you read it? So look, map are basically selective view of reality. Selective view of reality means in the map we try to represent the reality only. Okay, reality means what? Like suppose I want to show the national parks of India. So I will show those exactly where it is existing. Okay, suppose I can suppose this is India. Okay, suppose this is India, and I know that here we have a national park. In this particular place we have national park. So what I am doing, I am now showing, not a doubt that I am showing the location, but I am not maintaining the spatial information. That is the difference between a map and a drawing. Because in map we can also maintain the spatial information. Spatial information means its location, where it is exactly, and that is called as reality. If in the real world, if I am sitting at 20-degree north, okay, suppose in the real world I am sitting at 20-degree north and 72-degree east. So I have to show on the map exactly where I am sitting, and this is called as where it is. So in GIS, basically we try to show, or we try to, visualize two main information. One is where it is, and second is how it is. These two things we show in GIS. Where it is means you have to show the feature that you are trying to work on, whatever analysis you are doing for whatever feature. So where it is existing, that you can show with the help of is latitude and longitude. Okay, and how it is means, beside where it is, we also have to show the information as it is. If your sorry, if your house is in this shape, okay, so in the on the map you have to show it is in this way only. And that is visualizing the reality. Reality means what? How whatever is lying, and in whatever information, whatever shape it is there, we have to show it as it is. Okay. I'm again telling the students, please do try to join on time. Okay. Tomorrow, please be there by 8:30 only. Yeah. So now, so that's why the very first thing that we should learn is the map is selective view of reality. Selective view of reality means what? Again, this whatever I told initially, in on a map we can only represent certain information at a time. So if you are geologist, you will be emphasizing on geological features. If you are a population, if you are doing population studies, so your map will emphasize on population. Now you cannot mix and match everything. That's because of the scale. Okay, I'm coming to that also. Okay, now the second thing which is very important in mapping is the scale. Okay, scale means what? So whatever work you are doing, whatever application you have, if you are doing some research or you are doing some project, okay, so you have to first of all decide on what scale you will be doing the study. Okay, scale. So scale is basically the ratio between map distance and ground distance. Okay, so suppose I have made a map, okay, with a scale of, so for example, 1 centimeter on map is equal to 10 kilometer on ground. Okay, so how I will make the map? So suppose on a map I have to show suppose stadium. The stadium is of suppose 1 square kilometer. Fine. So now 1 centimeter is equal to 10 kilometer means I have to now divide this by 2 kilometer. Okay. Or suppose I on a map, I have to show a road which is 10 kilometer. So obviously this 1 centimeter will symbolize 10 kilometer on the ground. Okay. So this is actually called as a scale. Now the scale are of two type. One is small scale and another is large scale. And large scale. Small scale means if you are showing a large area using a very small scale. Suppose for example, I am making a map with the scale 1 centimeter is equal to suppose 100 kilometers. So this is a very small scale. 1 centimeter is showing 100 kilometer of ground. So this is equal to, this is suppose 1 centimeter. So 1 centimeter is equivalent to 100 kilometer on ground. So that means I am showing a large area, isn't it? So if this is 100 kilometers, so this means 200 kilometer, 300 kilometer. So I am showing a large area. So this kind of scale we will use to show the whole world or a country. Okay, so this is called as a small scale. So now, if you are making your map on a small scale, so how will you show the information? You will basically use the symbology of point. So in this scale, I can show a building in just a point, a small point, right? You cannot show the features in polygon if you are using a small scale. So more the denominator. If actually we have to represent this in fraction. In fraction, the scale is actually represented. So more the denominator, smaller is the scale. Okay. And again, suppose I am making a map with the scale of 1 centimeter is equal to 1 kilometer. So this is a very large scale. So how in the map it is representing? Suppose this is 1 centimeter. Now this is representing 1 kilometer of ground. So suppose the stadium is of 500 meter. So I can even show that stadium. If your house is suppose 100 meters. So even you can show your house also. Right. So smaller the denominator, larger the scale. And larger the denominator, smaller is the scale. And this is the scale is the reason why we cannot show all the features together in a map. Suppose if you want to show the rivers, then you want to show the Suppose you want to show each and every house. So rivers, if you want to show rivers of a country, you will always. Hello, is there any issue? Suppose you want to show the suppose you are a geologist, so obviously you will have to work on a very large scale, because geological feature you have to show in this way. You have to show the soil changes, soil differences. You have to show the fault line. So that can only be possible in a large scale. You cannot show geology in a very small scale. In the small scale, what we can show population. As I told, we can use the dot method for the whole world. Also, we can take a very small scale and we can show the population. So that's why in a map we cannot show everything together. Whatever
Just ma'am,
application. Huh?
hello.
Yes.
Just ma'am, basically map will mention 1:50,000. Suppose
Yes.
that
Yes.
at opposite basically you have seen the 1:50,000.
Huh.
What is the meaning in ground?
1:2 means the smallest unit of the map is equal to 1. Obviously we this is called as the uh, this is the ratio scale. Okay,
Yeah,
1
yeah,
is to
yeah, yeah.
50,000. So it symbolizes that one means what, the smallest unit of map is equivalent to similar smallest unit on the ground. Suppose in a map this is the most smallest unit, so it will this scale is representing this much of 50 times on the ground. So if in a map, obviously in a map you will have a most smallest, you can just divide the map into smallest part. So the most smallest part on the map is equivalent to 50 similar smallest part on the ground. So that's why you can see in the in most of the map, basically this graphical representation is always there, like 0 1 in this way. This is called as a graphical representation of scale. So and here it will be written as kilometer. So what this is meaning, it means that this much of distance on map is equal to 1 kilometer on the ground. So along with this ratio, you will always find the graphical. If you have a wall map hanging on your, any one of you have a wall map hanging right now, you can just cross check. With this ratio, there will always be a graphical representation. And this is the mostly used representation actually, because this is very easy to understand. Okay, so this is the most smallest unit on the map, and this is equivalent to this much of kilometer on the ground. Okay, so scale is
But
a very. Huh.
I understand, ma'am. But what is the distance in ground? 1:50,000. Basically, you have seen in the opposite map.
So I'm telling, no, the most smallest unit on the ground is equal to similar smallest unit on the map.
नहीं, मेरी बात आप समझ में नहीं, ऐसे मान लो 1:50,000 दिया हुआ है मैप में,
हाँ
तो
हाँ।
ग्राउंड पर उसका क्या वैल्यू है, उनका क्या?
इसका कोई आपके पास यूनिट नहीं होगा, तभी इसमें यूनिट नहीं रहता है, ना तो सेंटीमीटर है ना ही इंच है। ये सिंबलाइज करता है कि अगर हम मैप को, अगर इवन आपके पास डिजिटल मैप है, तो ऑब्वियसली द स्मॉलेस्ट यूनिट विल बी अ पिक्सल। ठीक है, तो वट एवर द डिस्टेंस ऑफ दिस पिक्सल, वट एवर द स्पेशल रेजोल्यूशन ऑफ द पिक्सल विल बी, दैट इज इक्विवेलेंट टू सिमिलर डिस्टेंस ऑन द ग्राउंड। ठीक है,
आपने
तो
बेसिकली देखा होगा टोपोसिट वगैरह में,
हाँ
पुराने वाले टोपोसिट आ रहे थे वो तो
हाँ,
स्मॉल स्केल पे ही होता है 1:50,000। अभी
तो
न्यू
वो
वाली आ रहे हैं।
स्मॉल स्केल में नहीं होता, स्टोपोशी सबसे ज्यादा लार्ज स्केल है, स्टोपोशी इज द लार्जेस्ट स्केल मैप।
हाँ, लार्ज स्केल पे ही है।
हम्म
वो पुराने वाले, न्यू वाले आ रहा है तो वो थोड़ा सा वो 1:10,000 पर भी आ रहा है।
तो मोस्ट इसमें टोपोशीट में ग्रिड्स भी होगा, तो आप
हम्म
ग्रिड्स के
हम्म
साथ भी इसको विजुअलाइज कर सकते हो। Grid is the most smallest part in a topo sheet. Yes, actually we have to use English because we have people around the world here. So if you are talking about the topo sheet, so in the topo sheet you will also have the grids. So a grid is again the most smallest part in that map. So one unit on the map will be equivalent to one grid, and similar, distance will be on the on a ground. Okay, and moreover in the topo sheet, if you, that's why in topo sheet we will also find the graphical scale encrypted as well. Okay, because the ratio format, whatever we are discussing right now is a ratio format is always little confusing for the layman. So for that purpose, the graphical scale is always encrypted on your topo sheet as well as on your map. You can just cross check, you will find the graphical scale also available. Okay, but the main point of saying is that in map we have two types of maps. So if we are talking about topo sheets or cadastral map, these are very large scale maps. So if I can even show you a cadastral map, which I don't have it right now. So cadastral map shows a very small village. Okay, so that is also a large scale map. So smaller the denominator, larger is the scale. Larger is the denominator, smaller is the scale. Okay, or this sometimes is a little confusing for the beginning students, for the beginners. So you can understand it in this way also. If we are talking about a large scale means what? Each feature will be highlighted largely. Okay, in a large scale means obviously we are showing a smaller area, suppose a village or a small town. Okay, so it will have a scale of, suppose we can say 1 centimeter is equal to suppose 1 kilometer. So here each and every feature can be highlighted, largely. You can even show your house, you can show each and every feature largely. So large scale means what? We are covering a smaller area. And small scale means what? We are covering a large area. Okay. So suppose if you ever work on a project, larger area. So suppose you got a project. For example, we are living in Delhi. Delhi is the capital of India. So suppose I get a project to make suppose I want to find out the area of each and every urban space of Delhi. Okay, so now I cannot work with whole Delhi as a whole. I cannot take Delhi as a unit, because this will mean I am taking very small scale. So I have to now divide Delhi into smaller parts, and I have to work for individual grids. And in GIS, we can do this. There's a tool called as fishnet. So with the help of fishnet, we can divide this whole area into smaller parts. And then we can make map of the smaller parts individually. So that's why scale is very important, because whatever work we are doing is totally dependent on what scale we have to do. Okay, moreover, if suppose I get a task of just pointing the major cities or major places of Delhi, so I can work in a very small scale, because I can take whole Delhi as one unit and I can just show the places in point. Okay, so whatever task you get, whatever work you get, you have to first of all decide the scale. I get queries from some research scholars also, mostly from geography. They always talk about the area that they want to take for study. Okay, so I always tell them to work in a very smaller area. Smaller area means what? You are working on a very large scale. So smaller the area will be, you can highlight each and every feature. Okay. Now again, it will depend on what topic you are working. Suppose you are working on climate change. So in that case, you can take a large area. You can work on a small scale. Okay, sorry, large scale. Okay, so that's why scale is a very important parameter, and it is sometimes confusing also. So that's why we have to very much clear with the scale concept.
Yes, ma'am. Yes,
Whatever your work will be, you have to first of all decide about the application. So suppose I want to find out a suitable site for garbage disposal in Delhi. So now I have to see the parameters that I'm going to take. So again, based on the parameter, I have to decide on what scale I have to create those parameters. So in GIS, forget about GIS. Just if we even want to make a map and want to do some spatial analysis, scale is a very important factor. Okay, so please go through the scale clearly. You will find about more about the scale concept in any geography book. There are a lot of book available, and surveying book as well. You can have a very good knowledge of scale then. The next is symbology. Okay, so
ma'am. Just a minute, ma'am. You discuss about the cadastral map.
cadastral map, actually I don't have here with me right now. I had, but I don't know how, somehow I deleted that. So today I won't be
Actually,
showing this.
just a minute, ma'am. Actually, the cadastral map is mentioned one. one 16 inch is equal to 1 mile.
Okay.
When I map layout, what is the scale in GIS?
So that will depend on what information you are showing. What is your requirement? I'm
No,
having.
no, no, no,
Hmm.
no, no, no. Actually, I'm asking you. Cadastral map in mention one is to a
Huh.
16 inch barabar 1 mile.
Huh.
I digitize cadastral map, then map layout. What is the scale in GIS?
In there, why there will be any different scale in GIS? Forget about GIS. No, scale is based on your main application. What you are trying to show. Got my
आपने
point?
मेरी कुछ पूछा नहीं. मैं क्या कह रहा हूँ कि आपका कैडेस्ट्रल
And
मैप
we
में
can
ग्रामीण से
discuss this because we have to extend this for, yeah, we can, even the participant are also saying, let me just complete it first, okay, then we will have the discussion afterwards, okay, because already okay, so
हाँ,
in the
ओके ओके
last we can have the questions, okay.
ओके ओके ओके.
Let me first of all proceed and clear out. So the next a concept of mapping is the symbolization. Okay, now the symbology that we represent on map, okay, that is again based on the scale. Yes, we will discuss later only. I'm again continuing. Yes, the queries and questions if you have, please, at the end we can discuss, because we are having this for 1 hour. I can understand people are even coming from office, they also have to have dinner and everything, okay, they are investing their time, okay. Anyway, so the symbology is also very important parameter, and this is also it also depends on the scale. Okay, suppose I want to show each and every building footprint. Okay, building footprint means what? I have to show the buildings. Footprints means in whatever, you know, pattern it is. Suppose for that, obviously I have to use a very large scale, right? Even suppose I can take a small locality of Delhi at a time. I will have to work on a scale like 1 centimeter is equal to suppose 500 meters. Then only I can show each and every building footprint. So then I can show in whatever, you know, shape each and every buildings are, right? And there are some tools, with the help of those tools we can show the buildings as it is. So now what kind of symbology I am using? I am using polygon, right? I am using polygon. Similarly, if I just need to show the locations of the building, now I can take a very small scale, I can show a very large area, and I can represent the buildings in how, in which symbology I can use point this time. So this symbology is also totally dependent on the scale. In whatever scale we are working, we should use the symbology in that way. Okay, so symbology and scale are totally dependent on each other. And this is again dependent on our application. Whatever application we are doing, whatever task we are doing, whatever project we are doing. So whenever you are working on a project, first of all you understand the main theme of the project, then you decide on what scale you have to do. That's why GIS don't decide. Okay, the question that you are asking, GIS don't decide the scale, we have to decide the scale, and we decide based on our requirement, based on the client's requirement. Okay, so that I cannot decide, no one can decide, it will be decided what is the client requirement, based on that we have to work on that scale. And in GIS we have this facility, we can change the scale by zooming in and zooming out, we can change the scale. But if you want to have a proper static map, then we have to, you know, clip the area as per the scale. Okay, in web GIS though, we can put whatever symbology you want to put in on web, you can put, and then you can zoom in and zoom out and visualize the thing. But if you are making a stagnant map in any desktop software, then you have to use a fishnet, divided in the grids, and then you can work and you can provide the symbology. Okay, the next thing which is very important in mapping is the projection. Projection means how you are representing the 3D earth surface in 2 dimension. Okay, so map projection is the technique basically to convert the 3D into 2D. So in GIS, what is been done actually to make the work easier, the whole world is converted into some coordinate system. Okay, here we use the technique of coordinate system to convert the 3D into 2D. Yes, so can we take up the queries afterwards, Jyoti? Someone has raised their hand, no? So after session, we can take up the query. Just note it down separately. So 5 to 10 minutes I will have after the session. So now the fourth very important parameter is the projection. Okay, projection is it is the technique of converting 3D into 2D, because what we are doing, we are basically making map, and we unless and until we bring this 3D into 2D, nothing is possible. Why I'm saying this? Because if you even make a line, suppose try this at your home. Just make a line. If you have a globe at your home, just try to make a line over your globe. If you will then try to bring this line in 2 dimension, it will look like this curved. So we cannot actually measure distance properly if we are measuring it in a 3D format. So somehow we have to bring this 3D into 2D. And that part is called as map projection. Means what technique we are using to do this, right? So in GIS, to make the things easier, in GIS software, the coordinate system, the technique of coordinate system is used, okay, to show the location or to convert the 3D into 2D. It's very simple actually. So coordinate means what? In coordinates, we have x-axis and we have a y-axis, right? So in GIS, basically we use two type of coordinate system. One is geographic coordinate system, another is projected coordinate system. In geographic, what is being done? This whole coordinate is divided into certain angles. Okay, suppose I am taking 10-degree angle, 20-degree angle, 30-degree angle, 40-degree. Okay, and then these are being joined in this way. This becomes the latitudes. And latitudes are what? The latitudes are the y, because it is crossing the y. Many students make it, it's quite confusing for the students, for the beginners basically. So this latitude are crossing over the y axis. So latitude are always y. Similarly, if we make this as a center and then we make more angles like this, suppose 10-degree, 20-degree, 30-degree, and then I'm joining this in this way. This becomes the longitude. This becomes the longitude. Okay, this becomes the longitudes. Okay, so now if I say that I am sitting at, look, in this way it is the northern, it is the north, this is the south, this is the east, and this is the west. Okay, so now if I say that I am sitting at 20-degree north and 10-degree east. So what does it mean? It means that I am sitting, suppose this is the 20-degree north and this is the 10-degree east. So I am sitting somewhere here, because this particular location is connecting in this particular point. So now if I give a command to my software that 20-degree north, 10-degree east, so it will automatically understand where I am. So with the help of coordinate system, we basically assign the location. Okay, and suppose I am working on a country. So country will obviously have four, extension. This will be the minimum latitude, maximum latitude, minimum longitude, maximum longitude. So this is how we can bring this much of area of the earth's surface on plain paper, just by having this four extensional value. Okay, let me just show in the Google Earth to make it more clear. So suppose I am working on India. Okay, so let me just, so now I am visualizing India on 3D, right? This Google Earth is a best replica. It is a model of the world. right? So I'm now visualizing India on 3D. So there are a lot of disadvantages of working on 3D. As I told, we cannot directly, analyze the things. If we bring this in 2 dimension, then working on doing some analysis is quite easier, right? So now, if I want to bring this much of area, the extension of India on my software, so I need to put this value. So if I'm putting this place mark at the center, at the southern part of India, so this is the minimum latitude. Latitude means what? This is the latitude. These are the latitudes. So India is between 8 degree 18 minute 44.49 degree north to, if I put it in the extreme north, 37 degree 8 minute 55.21 degree north. This is the extension of India. So now if I put this value on the software, so the software will automatically understand on which area I'm working. So not only this latitude, we also have to put the longitudinal value. So this is the minimum longitude of India. And if I bring it in the extreme of east, so this is the longitude, this is the extreme longitude of India. And what is longitude here? This is the longitude. So in this way, I can easily bring this 3D India into 2D plain paper, or 2D, I can make a 2D dimension map of India just by using this value, because once I will put this value on the software will automatically visualize India in a 2 dimension. And whatever parameter I will create, every parameter will be created in a 2 dimensional format. Okay, so this is called as the map projection in GIS for our AEs. To make the work easier in GIS, the coordinate system is being used. Okay, sorry. Oops. Fine. So these are some of the factors that we should understand while we are working with maps. Okay. Now let me quickly discuss about the data that we use in GIS. Okay. So we basically work with vector data and raster data. Okay, if I talk about the GIS data can be divided into various, in various formats. Okay. So if I talk about the type of data in various type, actually GIS data can be divided in various type. If I talk about the type based on format, then we can divide it into vector and raster. If I say that type based on integration, then I would say spaghetti and topological. So GIS data can be divided into various types. So next time if anyone asks you what are the types of GIS data, so please do make it sure on what format, on what basis they are asking, because GIS data can be divided into different types based on the characteristic. So if I now talking about the type based on its format, so we can divide GIS data into vector and raster. Okay, so first of all, let me explain what is vector. So vector are represented by point, line and polygon, but this is not the definition. The definition of vector is represented by x and y. Okay, what is that? Let me show. So vector means what? If I talk about the characteristic of a vector data, so first of all, it is discrete. Vector is discrete. Okay. And it is always represented by x and y. Suppose this is x axis and this is the y axis. Okay. So if now I am putting a point is the most smallest form of vector data. So this point will have one x value and one y value. Okay. Now if I am making a line, so for a line I have to click 2 times, one here, another suppose here. Now this will be joined and a line will have 2x and 2y, right? And these are actually, wherever we are clicking, these are called as the vertex. Okay. And the distance between the smallest vertex is called as arc. Now, if I'm again making a click here and another click here, and if these are joined, so this becomes a polygon. So polygon will have this much of x and y. And wherever you are clicking, these are called as the vertices. So basically the vector data represented by x and y. Okay, and x and y will have and x and y is actually attached with the vertex. Vertex is the most initial, thing that we do while creating a vector data. The click that we are making, the number of click you are putting, the number of vertices are getting created behind. More the vertices, more heavier your data will be. That's why if any one of you have ever downloaded Lancet data from Earth Explorer, you have an option of uploading shapefile. Sometime you will find your shapefile is not being accepted by the Earth Explorer. Why so? Because your shapefile, if your shapefile has got lot of vertices, so it won't be uploaded. In WebGIS also, if you are working with shapefile having lot of vertices, so it won't be it won't be uploaded. So in that case, you have to subtract some of the vertices. Okay, so
Yes.
basically the vertices are the x and the click that we are making. Okay, and if you are trying to upload some vector data, better you can convert the shapefile into KML. KML is a lighter version of the vector data. I will take up the query, okay, afterwards. Let me just complete the session first of all. Fine. So now, yeah, this I explained. Now, if I talk about the vector data format, so basically we have the major softwares are what? ArcGIS and QGIS, right? If I talk about the vector data formats available in ArcGIS, so in ArcGIS we have the geo database. We can work with the geo database. We can work with the shapefile. Shapefile is the mostly used, right? Because this is very flexible. This is very compatible. Then there are ARC info coverages and libraries are there. The CAT files are also in the vector format. Okay. If you are ever working with the OSM data, the street map files are also always in vector format. Okay. Then if you are working with SDE, spatial database engine data, sometimes you can get the data in SDE format. That is also vector format. If you're working with ASCII point coordinate, ASCII point coordinate means if you are getting the value in Excel and which is converted into .csv, that is the ASCII form of ASCII form data, format of data. Then if you are having the linear measure route data, that is also in, that we get in GPS, that is also example of vector data. Okay, now if I talk about ISRI geodatabase, so this geodatabase is basically used because it can store many files, many file format, and the biggest benefit of geodatabase is we can compress the data. Okay, in geodatabase the data is being compressed because the data is converted into, though I won't be going into so deep because I have some basic students over here. So basically whenever we are working with ISRI geodatabase, so geodatabase basically converts the data in a tabular form. Okay, so that is very useful to, that's very useful, as well as it obviously occupies very less space in your system. Okay, then we have the shape file. This is the second preferred vector format in ARC, and still now we use the shape file format the most because it is very compatible. Compatible means it can be used, it can be, added in any form, any software, whether you're working on ArcGIS, you're working on QGIS, you're working on Google Earth, you're working on ADAS, Idrisi, NV, everywhere you can add the shape file because it is very compatible. It has been created in such a way that it is very much compatible. Okay, then okay, now yeah, so if I talk about the ASCII coordinate data, so the GPS data is always in ASCII format. Then the survey data, okay, or if you are getting an Excel data having the X and Y are converted into CSV, these are all example of ASCII coordinate data. So these are some of the vector data format that we use. Now coming to the raster. Raster means what? The date raster is already represented by pixels. Okay. What is pixel now? Pixel are the smallest picture element, the most smallest part of an image. Okay. So, So when the data is created in pixels, that means it is in raster. Every pixel will have is represented by the row and column. Okay, so if anyone has ever worked on MATLAB, you might be knowing the importance of row and column, because in MATLAB we convert the raster data in tabular format. Each and every pixel is there is represented by row and column. But in GIS software, we visualize those in raster format. Okay. So in raster, we can there are various types of raster data. We have the digital orthophoto. Orthophoto actually created through using photogrammetric technique, where we overlap two stereo pair images and then we get the ortho. With the help of orthophoto, we can find out the altitude. Then we have the dam data. Dam is the when we further refine the orthophoto, it is converted into dam, and dam is used for 3D analysis. Then if I talk about some of the characteristics, so obviously it is quite continuous. Raster data is continuous. Continuous means what? Raster data don't have any specific boundary. Okay, suppose if you are getting the rainfall precipitation data, mostly we get the precipitation data in raster format. So raster don't have any boundary. If there is precipitation, so precipitation or this kind of natural phenomena don't have a specific boundary. It is unlimited. It is beyond boundary. So similarly, raster, this kind of data are called as continuous data, if it don't have any discrete information, whereas vector are quite discrete. In vector, we have vector data has got a specific dimension, a specific boundary. That's why whenever we are showing the boundary of an area, we always use the vector. We never show the boundary in the form of raster. Okay. It is another characteristic of raster. It is simple data structure. The data structure is quite simple, not complex like vector, because as I told, in vector we work with vertices. Sometimes the vertices, if the vertices is above beyond a limit, so you cannot work further with that. So that is little complicated. Okay. Raster are good for representing, as I told, to represent natural phenomena like wind, elevation, slope, then precipitation. Okay, so this kind of things we can show very well with the help of raster data. So basically, I tried to today emphasize on the parameters of map, and I talked about the data format that we use in GIS. Okay, so practical we will do it by tomorrow. Tomorrow we will be showing you how you can work with the raster data, okay, and a bit of the vector as well. Whatever we have discussed today, tomorrow we will be emphasizing on the practical part. We are not covering it more than 1 hour, because I can understand some of you are maybe late after office, so you have your own schedule also. Fine. So tomorrow, please do be with us right at 8:30. Okay, so that we can cover up the practical part. So tomorrow we will be emphasizing on GIS, and in the next weekend we will have a discussion on remote sensing, and we'll try to show some practical of remote sensing in Saga GIS. Okay. So if you have any doubt, you can call us on 730-320-7023. Now let me take, I have few minutes left with me. So quickly, you can ask me some doubts if you have. What's wrong with my screen? Is my screen visible? Yeah.
No, ma'am.
No, ma'am. No, no, ma'am.
Is it visible now? I don't know what's wrong
Yes,
with
ma'am.
the screen. Fine.
Just now I have some confusion, ma'am. Kindly clear, yeah.
Yes, I have this little time left with me. Huh? Please proceed further.
It's
Yes.
uh, actually you told me, ma'am, vector data represented in X and Y.
Huh.
If I have satellite data like that, the list 3 and Landsat, the
Huh.
mention in X and Y,
List is a raster data. Lancer is a raster. It is not vector.
but represented in X, Y.
Obviously, if it is georeferred, it will
Yeah,
have, along with the raster is always represented by the by its column, row and column. So now obviously if you want to work on GIS platform, so the GIS will not work unless and until you have the X and Y. So In raster, each row and column will have an x and y as well, along with the row and column data. But vector is created only based on x and y. So in raster, we have two things. One is the data of each row and column plus x and y. But in vector, it is solely x and y. Okay, so that's why in raster we don't, in definition we don't say that it is represented by x and y, because raster is not basically represented by x and y, it is represented by x and y plus the row and column value. That's why even I also emphasized that if you will ever work, if you will take the raster data in MATLAB, it don't care about the x and y anymore, it only work with the row and column value. Okay, but in vector it is solely x and y. Okay, so
Ma'am,
this
can
video
you
will be
please share?
uploaded. Yeah, this video will be uploaded on YouTube, so you can even have a look on it, and please do subscribe. Okay, yeah, what Jyoti, you were asking something, someone
Ma'am,
has.
Ma'am, my scale clear, concept is not clear, ma'am. I will call
Okay, please call
after
me
some
in the
time.
office hours. Okay, it's already 9:30, so after Monday or in the office hours you can call. Okay.
ma'am,
Uh,
can you share
I
this
will call
PDF on
tomorrow.
WhatsApp?
Sir, sorry, the whole day actually I am too much occupied. Even I am occupied in Sunday also, and we always
Uh,
share our official number. Okay, I don't mostly share my
yeah,
personal number. So on
I
Monday in
know.
the office hours you can call.
Okay.
Can you share this
Raghunath,
PDF?
you have
Actually, basic actually scale is very important things for GIS. You know.
yes, that's true. So I sir, let me take some more queries. So Raghunath, Jyoti, and Gaurav Mishra, you can proceed with your queries. And any
Ma'am,
one
can you
of
share?
you want to contact me, so on the in office hours you can contact on 7303207023. Okay, so I will be available on Monday to Friday in the office hours on in this number. Okay, yeah.
Ma'am,
हम्म
can you share this PDF on WhatsApp? जो PDF आपने पढ़ाया है अभी,
हाँ
और
जी,
जो पूरी
हम
जितने भी
this
थे नोट्स
PPT,
बनाने के लिए.
you're talking about the PPT.
Yes, ma'am, PPT.
Yes,
Sorry.
sure. I will be sharing this. Okay, no, don't worry.
Thank you, ma'am.
And video we will upload on YouTube. Okay, and video also
What is
we won't make it public. So those who have attended, I have even tracked the attendance. So those who are available, we will share with you people only the link of video, and the
Thank you,
PPT
ma'am.
will be shared. Don't worry. Yes.
Yes, ma'am. Thank you, ma'am.
Anything more?
No, ma'am.
Yeah, Jyoti Verma, you
Thank
were
you
asking
very much.
something. Okay, thank you. And
Thank you, ma'am.
yes, Jyoti Verma, you are asking something.
Thank
And
you, ma'am.
okay, thank you. And all the participants, please give your valuable feedback. You can just log on to our website and please give valuable feedback. It really motivates us a lot to do even better. Okay, and if you
Sure.
directly want to talk to me, so please call during the office hours. And tomorrow we will be again meeting. We will be having some practical hands-on tomorrow. Okay.
Yes, ma'am. Thank you, ma'am. Good night, ma'am.
Okay. Good night. Take care. Thanks for joining us and thanks for giving your valuable time.
Thank you, man. Thank you very much.